Let's start with a problem. You deploy an autonomous AI agent to do some research, and within 3 seconds, it reads your local credentials directory and exfiltrates your API keys to an external server. No prompts, no warnings. It just happens. This is ClawGlove. The red claws represent the agent's raw power. The crimson gloves represent the governance substrate, a tailored enforcement layer that surrounds every point of action the agent attempts to take. Over the next 6 minutes, we are going to install the ClawGlove sidecar, configure a strict tenant policy, and mathematically prove that an agent cannot escape its boundaries. Standard safety evaluations look at the model layer to see what an AI says it will do. ClawGlove sits at the execution layer. It intercepts what the agent actually attempts to execute on the network before it can reach the outside world. Step 1 is getting the infrastructure running. Open your terminal, clone the ClawGlove repository, and spin up the environment using docker compose upd. This initializes the governance sidecar. Notice that we are using a separate daemon, not an in-process library. This allows the sidecar to monitor system-level events, like process spawns and file modifications, using eBPF enforcement that is isolated from the agent's memory. This diagram maps the network topology. The AI agent container is placed on a Docker internal network, which strips away its default gateway. The ClawGlove sidecar acts as the only route to the outside world. If the governance layer goes down, containment remains in force. Watch what happens if we manually stop the sidecar daemon. The agent immediately loses all internet access. There is no fallback path. Integrating the gateway directly into the network topology makes security a structural requirement of the infrastructure. Let's look at how we define behavior. On the left is our tenant policy YAML file. This is where we strictly allow or deny specific tool actions and LLM endpoints. On the right, you can see the sidecar logs tracking activity in real time. If the agent attempts to route a request through an unverified LLM provider to bypass monitoring, the sidecar catches it and drops the connection instantly. Because the sidecar monitors execution events at the kernel level, it blocks advanced adversarial maneuvers, like establishing stealth cron persistence or attempting sub-process self-replication. Every single one of these violations is logged by the threat escalation tracker. The first few blocked actions flag the tenant status as elevated, alerting the operator while the system continues its automated enforcement. Once the agent reaches 6 violations, the tracker activates a total quarantine state. Every subsequent action the agent attempts is automatically denied. Governing at the execution layer neutralizes the agent's ability to persist in the environment, regardless of how compromised its internal logic becomes. To prove this containment works, we use a metric called Governance Escape Entropy, or H-escape. This calculates the total diversity of attack vectors an agent can successfully probe. Think of an ungoverned agent's environment like this maze. It explores multiple paths, scoring entropy above 1.5 bits. Applying ClawGlove policy locks down most exits, dropping entropy to 0.62 bits. Under quarantine, the final path is cut off. Entropy hits exactly 0. Collapsing the agent's possibility space to 0 provides mathematical proof of total containment. To calculate that score for your own system, you run CGBench. This certification suite runs a 5-layer adversarial simulation to grade your agent stack. Testing autonomous systems creates a unique risk, evaluator compromise. As an agent gains file system access, it could rewrite the benchmark script that's grading it to hide its own violations. To prevent this, ClawGlove uses benchmark sovereignty. The testing directory is protected by OS-level access control lists, blocking the agent from modifying the testing environment. We have to maintain a clear separation between the subject being measured and the instrument doing the measuring. For any system where the agent can modify its own environment, these safety tests must be physically locked away. After running the suite, the final scorecard generates. This stat caught 100% of the injected violations and achieved the highest rating, G5 Provenance Certified. In a few short steps, we took a system vulnerable to immediate exfiltration and locked it inside a mathematically bounded architecture. Now it's your turn. Pull down the repository, run CGBench against your own agent stack, and post your H-escape score in the comments below. Effective autonomous systems must provide a verifiable proof of containment before they can be trusted with production environments.